If you're in the security space right now, or maybe you're not even in it, but you've heard about it, you've most likely heard OWASP. Now, OWASP is essentially a set of security standards from a best practices perspective. And up until this point, we haven't really had anything around Kubernetes or orchestration in general to really get inside of that OWASP top 10. However, Jimmy Mesta, the CTO of KSOC, has put together his top 10 list for OWASP top 10, and we're going to be going over all of it. So we're going to be going over 1 through 10, why they're crucial, and how to mitigate these things if you have them inside of your environment. So with that, let's go ahead and jump right in. All right, so here is the OWASP list. Now, as you can see, if you literally just Google OWASP top 10 Kubernetes, this is going to pop up, or you can see the link down in the description below. So let's actually go into this. Now, this is really geared towards if you're a security practitioner, or you know what, even if you're a DevOps engineer, platform engineer, SRE, whatever, if you're the person that's implementing security practices for Kubernetes, or if you're part of the team that's doing it, you're definitely going to want to read this and you're going to want to listen in. So with that, let's go ahead and jump right in. Now, if I click on any of these links, it's actually going to take me to GitHub. So if I scroll down here, I'm actually just going to open up GitHub. And as you can see, we have the top 10 right here. So we're just going to click through right from here. Now, if we click on the first one and we go ahead and we scroll down and actually zoom in a little bit more, this is really around Kubernetes manifests and how they can contain bad practices overall. So if we go ahead and if we scroll down here, the first one and the biggest one is application processes should not run as root. So if this container gets compromised and it's running as root, it's going to have the privileges to start multiple malicious processes. So if you're running any containers as root, the first thing you should do is definitely stop doing that and specify a user or service account where needed. So you also want to make sure that you're specifying read-only file systems, and privileged containers should be disallowed. So if you set a pod to privileged, the container itself can access other resources from a kernel standpoint. So you want to make sure that you're not doing that. Now, how can you do this? Well, of course, from a large organization standpoint, this is going to be tough. But what you can do inside of the Kubernetes manifest is set the security context. Next, let's take a look at the second. So that's supply chain vulnerabilities. If we go ahead and if we open that up and scrolling down a bit here, a lot of this is around security vulnerabilities around container images. So you want to make sure the image integrity, you want to make sure where you're getting the image from is scanned, is secure. You know what's actually happening inside of the container image versus just running whatever you want. Now, this also goes for base images from, let's say you're using an Ubuntu latest base image or an Nginx base image. Maybe you might not want to do that, or maybe you might want to scan it to ensure that the vulnerabilities that you don't want to be there aren't. Now, scrolling down here on how to prevent this, the key parts are image integrity, which we kind of just already talked about, SBOM, which provides a list of software packages that a given software should contain, image signing, so maybe you have a SHA-256 that you're looking at from a Docker container image and you want to make sure that that lines up with what you're expecting, and scan for any known vulnerabilities. Now, a big one that stumps a lot of organizations, and I've talked about a ton of times, a bunch of security experts have talked about a ton of times, is RBAC for Kubernetes. Now, RBAC is literally, the golden child to what you can do and what you cannot do inside of your Kubernetes cluster. So for example, the default service account that a lot of people don't not specify in pod manifest literally have access to everything. So if you're, for example, deploying all of your Kubernetes pods with the default service account, you're going to have some security vulnerabilities there. But thinking about RBAC from a user perspective, every user that gets created gets a kube config, and that user can then access the Kubernetes cluster. So what permissions do you give that user? Well, we always want to start with least privilege, and we want to work our way up. So for example, if a user is just creating deployments, but they don't have to create ingress controllers, don't give them access to ingress controllers. So scrolling down here, we can see that we can set up a cluster role binding, and that cluster role binding has a reference, and that reference is going to be from a cluster role that you've created, and that cluster role can contain, for example, this person can only list view pods. That's it. That's all that they can do. So if we scroll down here to how to prevent, it's really just around creating good RBAC permissions for users, for service accounts, ensuring that the service accounts that are being created, the users that are accessing your cluster, you know exactly what they are doing. Next, policy enforcement. It's a big thing. So if you're familiar with, OPA, for example, or the Open Policy Agent, that's a way to set up best practices and standards for your Kubernetes clusters. So scrolling down here, we can of course see that we should be setting up some type of policies. And these policies could even be what service accounts can do, what users can do, what other resources inside of your Kubernetes cluster can do. You want to make sure that you're setting up these policies across your entire environment and your entire configuration. Now, if we scroll down here, we can see how to prevent is essentially setting up some type of OPA policy. So for example, OPA has something called the Kubernetes Gatekeeper. Now, the Kubernetes Gatekeeper allows you to set up OPA policies for your Kubernetes clusters. Next, and arguably one of the biggest ones aside from RBAC, is logging. So we have the ability to have metrics. We have the ability to have traces and logging. And with those logs, you know what's happening inside of your environment, whether it's a failed pod or there's some type of DDoS attack occurring or some type of known vulnerability. You should be logging everything and anything that's coming out of the API. And you know what? It can generate a lot of logs. However, if you're not generating those logs, you're not going to know what's happening in the environment. And taking it a step further, if you are generating those logs and you're putting it inside of a log aggregator, do something with those logs. Don't just let them pile up. You want to be able to take some type of action. And the way that you can do that is by setting up a good observability tool. Pretty good one from, a Kubernetes standpoint that a lot of people use is the Grafana and the Prometheus combination. You can have Prometheus to kind of show you a UI and the monitoring aspect of things in real time. And then Prometheus can act on the logs that occur and generate alerts. So if we scroll down here, there's a bunch of different things that we can be logging in for: application logs, container logs, OS logs, cloud logs, network logs, and anything that's coming out of the Kubernetes API. Next, authentication, authorization. A lot of this has to do with RBAC, but there are some other sides to this as well. So if we go ahead and if we scroll down here, we can see that there are a lot of resources inside of Kubernetes that need access to the Kubernetes API, but there are also a lot that do not need access. So if we scroll down here, we can see a good diagram of a user coming in and a pod coming in, and ultimately what those two need access to. Now, a lot of the times, pods don't need direct access to the Kubernetes API, but the user does. So when you're creating service accounts, when you're creating user accounts around pods and users, these are going to be two very different methodologies that you're going to be using. Again, least privilege. So if we go ahead and if we scroll down here, from a user perspective, you can use something like OpenID Connect. If you're in Azure, for example, and you're using an Azure Kubernetes service cluster, you can use Azure Active Directory. It's built in right there that you can use for your, OpenID style authentication from a user standpoint. From a pod standpoint, from a Kubernetes resource in general standpoint, you always want to be using service accounts. You want to use the default service account, and you want to make sure that those service accounts that you're creating with cluster roles and cluster role bindings have the appropriate permissions. Again, going back to what we were talking about with RBAC, you want to make sure that it's least privilege. You want to make sure that the service accounts only have access to what they actually need. All right, so now let's talk about number 7, which is network segmentation. So if we go ahead and if we scroll down here, really this is all about network traffic. Now, when we're thinking about pod-to-pod communication, when we're thinking about service communication, sometimes people call it east-west traffic, all of this is 100% unencrypted. So how can you kind of think about, encrypting this traffic? How can you think about securing this traffic? Well, service mesh comes into play, but that's pretty advanced. So if you're not there yet, maybe you might want to think about a level down, which, maybe you could use something like a network plugin / framework like Calico, which gives you the ability to encrypt pod-to-pod communication. Now, the other piece of this is cluster communication. So you have cluster A, cluster B, cluster C. Eventually, these clusters are going to have to communicate with one another. And what can you kind of do about that? So if we scroll down here, we can see that there are some native controls for multi-cluster, and then there are some native controls for network policies. Again, going back to this whole OPA thing, right? You can set up certain policies. You can set up policies with OPA. You can also set up policies that are kind of native to Kubernetes in itself. So if you scroll down here, you actually have network policies that you can set up to allow traffic, to decline traffic, whether it's egress, ingress, etc. Scrolling down a little bit more, we can also see, talking about service mesh, right? So again, it kind of depends on where you are with your Kubernetes journey. The first step is to, if you're using a network framework or plugin like Calico, you can do some encryption there. Next, you can set up some network policies. And then the third and more advanced level is a service mesh. One of the biggest ones, I feel like I've said this a few times now, but I swear this is actually a really big one. Secrets management. So by default, Kubernetes has a way to store secrets, but it uses the OPEC standard by default. And the OPEC standard by default is not encrypted at rest. So for example, when you're storing secrets in Kubernetes the native way, it's actually in plain text. When secrets are kind of passed and used by pods, for example, they're encrypted, but when they're actually stored with Kubernetes secrets, they are plain text. So what can we kind of do to resolve that and get away with that? Well, not get away with it, but get away from it. And the way that we can do that is with using, another secrets management tool. So maybe something like HashiCorp Vault, for example, that you can use to store your secrets. You can also look at encrypting the secrets that are on the Kubernetes cluster. You can look at something like Bitnami sealed secrets if secrets are in source control, which I feel like a lot of people don't like to go that route, but it is available when needed or when something like HashiCorp Vault won't work. Make sure that you have auditing in place. So even if you have all these things set up, you have a really solid security team, you have a secrets manager like HashiCorp Vault, your secrets are encrypted, you still want to make sure that you're auditing, you still want to make sure that you're looking through source control logs, or not manually looking for them, but making sure that they're being ingested somewhere so you can get an alert if a secret is revealed. And then next we have cluster components. So this could be anything from etcd to the Kube API server to the kubelet. The thing that you really want to think about from a cluster perspective is, this is Kubernetes, but remember, it's just infrastructure. It's just virtual machines that are running Kubernetes. So the control plane, the worker nodes, they are just VMs. So you have to make sure that those virtual machines are secure, and then you have to also make sure that the Kubernetes components are secure. So you want to make sure that there's certain misconfigurations that don't exist. For example, you want to make sure that there's not authentication from an anonymous standpoint happening on the kubelet. You want to make sure that authorization checks are always performed when communicating with the kubelet. You want to make sure that etcd is as secure as possible. Remember, etcd is like Kubernetes database, so it's literally storing all of the stateful data. So if that goes away, or if it gets compromised, you're gonna have a big problem on your hands. And then of course the Kube API server. I read an article probably a few months back at this point that over 900,000 control planes were exposed on the internet. This is a big deal. Sometimes Kubernetes clusters have control planes with public APIs attached to them. This can be a big security concern. Make sure that you're looking into things like that in the low-hanging fruit even before you're deploying in a cloud service or on-prem. Now, there's a few different ways that we can, prevent this. One of the biggest, I would say, is CIS benchmarks, severity checks, any severities from the National Vulnerability Database. So when you're scanning clusters, you can get information back from certain tools saying, yep, this is a vulnerability in the National Vulnerability Database or in a CIS benchmark, and it can tell you what you should be fixing. So definitely make sure that you're always running these scans against your cluster. And then last but not least, we always have outdated components in our environment. Now, if you have an old school infrastructure background, a sysadmin background, you know that in most environments, there's some things that are out of date, and an old ESXi version or an old Hyper-V version or an old version of Windows Server or an old version of Exchange. You get where I'm going with this. Every environment kind of has these, older vulnerable components. With Kubernetes, it's no different. So for example, some Kubernetes API versions have vulnerabilities, and because of that, you would have to update the Kubernetes API version. So if we go ahead and if we scroll down here, we want to make sure that we have everything up to date as much as possible. And this is from the CNIs, the CSIs, the Kubernetes API server, any tools and platforms that you're using with Kubernetes. So like Argo, for example, you want to make sure that everything is up to date with whatever you're using with your Kubernetes cluster. And the best way to prevent this is, from an audit perspective, track the CVE databases to make sure that if you're running a version of something that you're using with Kubernetes or the Kubernetes API itself, you want to make sure that that's up to date when needed. And of course, you always want to make sure that you're doing continuous scanning and minimize as much third-party applications and dependencies as possible. And with that, that's the OWASP top 10 for Kubernetes. Now, I do highly recommend checking this out online, reading through it more thoroughly, and really getting a grasp and understanding of what you can do to mitigate all of this moving forward. Again, thank you so much to Jimmy Mestis, CTO of KSOC, for putting this together for us. We really appreciate everything that, he's doing for the security community and all of that good stuff, because it's super crucial. Security is something that is not looked at all that much. If you look at an organization and you look at how many developers there are compared to how many security engineers there are, the number is drastically low. So these types of lists really help us as platform engineers and DevOps engineers get up to snuff with Kubernetes vulnerabilities. Thank you so much for watching. Really appreciate it, and we'll see you again next time.